That. There we go. Just by asking questions, you guys remind me to do things I've forgotten about. Thank you for asking questions and inevitably reminding me of things I would have otherwise forgotten. So Chakma asks whether, oh, I notice you're keeping your editor in one window and don't enforce a character limit on width. Is that a general MO at the places you work? With widescreen monitors becoming pretty much the standard these days, you don't really see many people enforcing small character limits anymore. Obviously, you don't want a piece of code that, just kind of goes off into forever as you keep typing, because suddenly this becomes an unreadable mess. The moment that somebody tries to modify it, you have to sit here and go, okay, wait, this code does what? And you want to be able to keep everything that's in the current context kind of in an area. But as far as like character limits, those are now bordering on, for lack of a better word, kind of archaic practices. If something's obviously going to break off and be far too long, I will dump it on the next line. But I do like having also all my code that is relevant on the same line if possible. My own music got a little loud. As much as I love Bastion, I also love staying focused by not getting a little too into my music. Antiquated is another good term, yeah. Alright, so first fix. Looking into why the game world seems to be pretty much, it looks like it's almost twice the size of what it should be. So let's dig into that first. Somewhere there's a 2D vector that I'm passing into my terrain generator. Ah, okay. Maybe it's not a 2D vector. Maybe it's just this one value. So this kind of tells us how big everything should be. I'm guessing that I'm generating random points, not in the half space, but in the full space. So instead of saying negative size, times 0.5, so that the size that I input is the size of one length instead of the size of a radius. I'm guessing that somewhere in the code I'm using just straight up size instead of the actual setup numbers I expect. So the question is hunting down and finding where that might be taking place. I'm also going to guess that that probably happens somewhere in the point generation, because I'm thinking it's generating the points in a small area and then telling it, oh, but the actual size is in here. Actually, that would mean that the point generation is fine. Whoops. Oh well, we'll see. So generate cell points. Seems like an obvious first place to look around. But it looks fine as long as I pass it decent values. What is this range? This range looks correct as well. Here's our point 2D that's got one side and the point 2D that has the other. So that looks correct. I hear noises from the dog, but I'm kind of worried. Yeah, so the engine has a pretty good set of math functions. Included is a fair number of good random overloads that are nice to have. Because usually when you call random, it's just an integer from 0 to whatever int max happens to be. That's kind of your standard. Or the other thing I've seen is a lot of people will write a floating point that just returns 0 to 1, and then kind of lets you modify it and mess with it as you please. This has a lot of good overloads that kind of give you the functionality you need. One of the many joys of working in a lovely engine like this. Okay, so the cell points look fine, because this range is correct. And that's all that's getting passed into here. So I'm going to check in on the triangulation next. But once again, it uses the same range. I'm just going to put a breakpoint in here and give it a spin and see what it looks like. Sometimes it's easier to just kind of check things as you go. So remember, our size was 10, so the 2D vector here is from -5 to 5, which seems correct. It does make me wonder what we're doing that would generate such huge points, or that would generate so many points that are just inside, so far inside the system. I am Deity. C4 is the game engine by Terrathon that I'm using, and it can be swapped between 32 and 64-bit. It's all written very, very well. Pretty much every part of the engine that can be flexible is. So all the points look like they're in the right place. It's so bizarre that I'm not really able to find. I kind of figured I would very quickly and easily figure out what was causing me the pain. That is this kind of bad range. But it looks like it's being used all correctly, so let's see. The Verneuil cell graph, and that's kind of the last point where we ever check things ourselves. We don't really ever dig much further. This is so incredibly bizarre. Okay, maybe we can find a spot where, because we can see all the places that size is used, but I'm not seeing even any spot where it's being really abused. Everything is handed this range afterwards, and the range seems to be very correctly setting up all of our details. Cell area, we clamp it. Yeah, no, this is incredibly bizarre. Kind of figured this would be a nice easy thing to just like knock out while people were like filtering in and doing their thing, but why is this point so friggin' far out? That is definitely way too far. I wonder if I got a bad point in the system. Or, let's actually watch some of the point generation, just to kind of take note of some of the points that do get created. Because maybe this is a valid space, and maybe the big issue here is that maybe the issue is that my random number generator is not creating a random enough spread. So it might be jumbling all the points in the center, or it might be kind of throwing them haphazardly, where we end up with this collection of them in the middle and then kind of less further out. I'm just kind of frazzled because it looks nice in the center, and then kind of as you go further outwards, it seems to get a little more sparse until we end up at this point where it's like, well, now it's kind of ugly, so what the heck happened? So let's, yes, okay, random number generator, go. And then we put it into a range variable, that's all fine. And I accidentally stepped past what I needed to. Where's that point generator? Ooh, and there's a relax points function. That might actually be what I use to clean this up. My partner's already written a fair hunk of the innards of some of this, so I'm not too worried about all of this. It's just kind of niceties that I want to make sure work themselves out, especially before we go into a system that's a little more flexible, is essentially what I'm looking for. I want to make a system that I can have, here's one square of scenery and terrain, and then have the next one loaded in separately, so that we can stream in what we need, so we don't do something like a 5-minute terrain generation every time the game starts, and also so that when we save this, it's not this like monstrously ugly thing to save. We want this to be a fairly decent system that serializes okay, so that saving and loading your game doesn't generate, 200 megabyte files or anything absurd like that. So, okay, these points... Whoops. I forgot to put my breakpoint in the right spot. So these all look like good values. It's not generating anything that I don't expect. In fact, it's generating kind of a good spread all over the place. I'm seeing some points out near the edges, some near the center. It's kind of random, as you expect it to be, because it's a random number generator. Okay, so we can kind of rule out our points being bad, which means it's either somewhere in our triangulation that we're doing something silly, or it's somewhere in the graph generation. I do remember that at some point we had some code that would essentially generate an infinitely long circle, and then because I was generating an infinitely long circle, that would break some of our terrain generation. So I'm kind of tempted to hunt for that again, find where that code went, and then see what points are being created out of it. Unfortunately, I don't exactly remember where that code is anymore. It's been so long that I'm not exactly certain where all that went. So we've got 100 points. I'm tempted to make the world tiny just so I can watch every little facet of it happen and just kind of ensure that everything is correct. Although if we can't, I'd like to figure it out in one broad stroke. Generate our circle. These triangles look alright as well. Sadly, since I haven't written any of this code, I kind of don't really have a full understanding of it. I'm kind of learning about it and staring at it as I go, trying to just kind of understand what the heck is going on here. Then we sort the vertices. We add edges as expected. Like, nothing here looks incredibly bizarre or broken or like we're doing anything really frightening. So I do need the terrain information anyway, but for areas that you haven't discovered yet, and also for sets of not just the terrain, but we're also talking about things like having the ability to turn on and off entire sections of the world, because obviously your computer can only handle so much processing, and especially people who have less powerful PCs. We want to make sure that not too much of the world is loaded in at once, and what happens is we can kind of cheat and say, well, when you load in an area that hasn't been loaded for a while, you can do one of two things. You can pull a Minecraft where the world just hasn't changed at all in that section if things are unloaded, or you can go through and essentially time-lapse everything that should happen before the player can see it. So you start preloading the area, and you say, okay, the area is, 3 game weeks behind where it should be. So let's run it through, and every frame we're going to try and catch up a day worth, or we're going to try and catch up, a couple hours worth. And that allows us to essentially expedite the process back to where it should be, so that everything stays in sync. That will be a fun day that I'm actually not looking forwards to, because time traveling code is always frightening. I did it a few times for networking games, or networked games, I should say. Man, that stuff is crazy. It seems error-prone, but it's also very, very controlled. Since that region has not had any player control manipulations happen to it, so if it's far off enough that the player hasn't even seen it until recently, chances are that the player isn't going to have had any effect on it. There isn't really so much of a kind of butterfly typhoon effect going on here. It's so isolated that we really don't worry about it a ton. Also, most people tend to kind of nerf their own AI when you do stuff like that, so that they don't make too much progress when you're not looking. It's kind of a way of keeping everything in line, so you don't have some superpower nation, stomping everything when they've been across the map doing their own thing, completely unmanipulated the entire game. Seems error-prone, but time-traveling code exists to some degree in pretty much every single networked game you've ever played. Man, these points look bizarre, but they're fine. They work. This is all completely valid data as far as I can tell. Wait a minute. Wait, what was that? Dang it. I stepped and skipped right past. Whoop, I just did it again. So I'm staring at this little watch window. I point at my screen as if you can see, but I'm staring at this little watch window in the lower right hand corner. And I'm seeing, there it is, here, this guy. What is this? He's at a Y position of 173 with a Z of 169. Not good. Time to figure out what the heck's going on. Okay, so... So, the points we're dealing with... So the points we're dealing with are the edges, right? Here's 2 user-generated edges, because if you look at the point count's always 100. That's how many points we generated in order to come up with this world. Now, we added in 4 more points to encapsulate the entire area. Oh boy. We're back to kind of the issue I saw in the first place, though. So, remember a long time ago, our terrain was completely borked, and I removed a fix. I bet it's in here still. Excuse me, dog. Alright, my apologies. So this code still exists, but we're coming up with a... We're kind of back to the issue we had before. This is generating some really wild numbers when we try and calculate a circle out of these points. Because the points are not inherently bad. If we pull up the point array... Excuse me again. Nope. No. Go back outside. He started scratching at the couch, and I have to keep stopping him. Otherwise, I'd rather he not do damage to my couch. You might even be able to hear him in the background complaining. Because he wants to do it, but he knows he'll get in trouble. Oh, doggies. Okay, so... So... we are generating some funky data in here. And my big problem is that when we generate this weird data, it doesn't really show except for at those edges. So part of me is curious, first off, if there's a better way to do this, because I generate these 4 points, and then I proceed to set in the 2 triangles that make up those points, and that we then break up into all the little triangles on the inside. Which seems like it should be fine. That's the thing that makes no sense. You look at this and you kind of go, well... it seems correct. But it's still generating bad data, so... maybe I won't end up fixing this. I might actually ask the guy who worked and wrote this code in the first place to look into it. I was hoping to kind of clear that up today. I wonder what happens if I generate really tiny terrain. Just for kicks, let's do it. Just to see what the heck the game does. Oh gosh. Things start to break down. I'll tell you that much. Oh, also I need to do a little bit more checking, clearly. Granted, this isn't something that should really happen too often. This is if we ever run out of all trees in the game crashes. Obviously, that's not kind of the best case ever. There should always be a tree somewhere in the world, but we should at least not have the game crash if something like this happens. So it looks like it's taken care of everywhere else, which is good. If we can't find any more trees, we simply do something else. Okay. Well, we fixed one bug, at the very least. But you can see it's even generating, like, terrain without... there's not even enough space for people on this terrain. In fact, let's see if we can't turn that up ever so slightly. We did have a resolution check at some point. So, what I'm gonna do is I'm gonna add in, we don't just have size, we also want cells per square unit. There we go. And this should give us a little more control over our terrain generation eventually. Alright, so cells per square unit, we're gonna throw this one out and replace it with an actually valid number. And for now, we're gonna say, let's try like 10 cells per square unit. We'll kind of play with it from there. See if we can generate like a tiny little world space. So yeah, here you can see it's really generating this bad data. This is valid. This center area is valid. But this over here, that's clearly wrong. Something in here is very broken. So I think rather than spend a bunch of time trying to look at math and mess with code that I am not familiar with, I'm actually going to pass this bug off. Kind of a cheap thing to do, but I don't think I've actually logged it, so I'm just going to quickly toss in that a new bug. And what is the description? Get circumscribed circles. Generates bad data when dealing with initially created triangles. Ends up, we'll say, outside valid range. There we go. Okay, now that that's tracked, hopefully I can pass it on easily enough to my partner, and that should be easy for him to fix, or at least easier, just because he's more familiar with this code than I am. So at this point, either I could spend hours on it, and probably this entire stream just to dig up that one problem, or I can let him do it in probably the space of a half hour to an hour, and I can just do something that would be more productive, which is honestly the way I think we want to go. So let's see. I had one more bug I wanted to fix before I actually started in on the gameplay feature today. Ooh, let's make the world bigger again, though, because tiny little worlds like that are no fun. I'm curious what happens if I have my resolution turned way up. Oh man, look at that. That's some interesting terrain right there. Lots of cells packed into a tiny little space. It's kind of cool, honestly. I kind of like it. If there were an easier way to place... I don't think there's any valid way I can place something on this terrain. But it would be neat if I could. If I could find a way to level out terrain a little bit more. Might be worth it. This is kind of a nice thing. Let's turn down the resolution again. Much better. Much more manageable. Although then again, I call it more manageable, but there's still... I don't know, there's still a lot of space here that I could be handling better. I'm still continually just kind of messing with it because I'm seeing edges and details I don't like. What just broke? Something here got unhappy. That's interesting. I might have to add this in as well. When you generate terrain large enough, things just kind of break. And this is kind of, we're back to that reasoning on like, why don't we just generate one giant terrain and then save it all at once? Why do I want smaller little chunks? And this is kind of why. If we generate a terrain that's too large, it eats up too much memory all at once. Also, what is breaking in here? My gosh. This is incredibly bizarre. And once again, it's back in this code that, yeah, we modified it, but it shouldn't be breaking like this. So it says there are 30 vertices, but then proceeds to say it also has vertices that go up to 1,150 at minimum. So something's not right when these numbers start to get large. That's a little frightening. Let's see. Maybe it's just the fact that this size is way too large for it. Although that honestly shouldn't be the case. I'm actually going to add that to the Trello list as well. More bugs to log. Not the end of the world, just scary. Generating large landscapes causes game to crash. Causes, I guess I should be more specific, causes the game to crash inside mesh generation. Terrain mesh generation. The more detailed I get, the less digging my partner will have to do if he ever ends up looking at some of these. Alright, so on to what I'm actually trying to get done today. This works, mostly. I say it works, but it only works most of the time. For example, if I start to move the camera, you see it only updates every once in a while, and I can actually leave it behind. Especially when I do things like rotate, it gets in funny places. Or if I just move the camera altogether, it's not being told to update. So we're going to change where things are getting updated. And we're going to actually swap it over to a better spot, just so that it's a little clearer and a little more easy for us to control when each tool in the game UI is updated. Okay. I was having some frame rate issues, so I just turned down the system for a moment. Turned down the size of the terrain so it has less to chug on. We are in a debug build, and debug builds are notorious for being a lot slower because they allow you to debug. You can't optimize anything because it has to run like the code you've written, and they can't take any shortcuts, or else the code that you've written separates too far from the code that's being run, and it becomes really difficult to see what the heck is going on. So, we've got our terrain. We're going to have to move the tool from where it is into a place where the game world can access it. Because ultimately we want it to update per frame. This does give us some benefits. It makes the game run smoother, so we'll have less giant spikes of processing. Because if I press a key, or I press multiple keys in one frame, right now our input system would log each event in the same frame, and then attempt to do multiple collision checks for each event. So we might have, like, if I mash a ton of keys and click the mouse all at the same time, we might actually be able to generate up to 4 or 5 different collision checks on a single frame. And that's not so good. We'd have a spike, and suddenly we'd be back down. And spikes like that aren't terribly great. You want, if anything, a smoother frame rate than anything else. Losing a frame is not the end of the world, but when that one frame starts to eat up the frames on each side of it, suddenly bad things happen. So we're actually going to do a collision test every single frame, and we're going to worry a little bit less about multiple events happening at once. So here's our input handler. So 2 things can happen. One, we can just have the world tell it to update. And that might be the right way to do this. Because at the end of the day, we don't really want anything too crazy going on. We don't want to be too clever and kind of outsmart ourselves later. Now we will have to add a little more tracking data, probably inside the tools, to hold the new data that we want to store. Because we're going to be doing this per frame and not as the events come in. That's the static. That's the other static. So let's try. Also, the other nice thing this gives us is that we can turn off the input handler for a certain amount of time, and this will allow us to essentially stop handling certain events. We can a little more controlled handle each event as we want to. So say we want to run a cutscene, or we want to bring up a game menu. We can turn off the in-game input handling, and that will save us a couple cycles, and we'll stop taking care of events that we don't want dealt with, such as mouse clicks and keyboard presses when you're not actually in-game. And no stop troll fur? No, not my engine. Definitely not my engine. Yeah, if we add cutscenes, they gotta be skippable. I don't even want to start in on that road. Okay, so how do we do this? We have to swap from this event-based system that currently exists to something that's a little more... How do we say it? We want to swap to something that's a little more... I guess it's a polling-based system. We want to switch from events to polling, where every frame, you know, we say, update the tools, update them again. If anything changed, if we have any reason, update the tools. Now what we can do to keep us from kind of overrunning our system is we can have this, we can have an invalidate tools boolean that we only set on frames when things change. And that would actually clean up our code a little bit in terms of processing time. So we need the game world to call this update tools function, first off. And we need to figure out a good space to put it. Having it kind of happen after everything in the world has happened might be a good thing. Although I don't think I want to do some world processing without dealing with the controllers having moved and done their processing first. Otherwise, there'd be a one-frame lag between a player placing an object and the object actually becoming something active in the scene. And we don't really want that lag. That might either cause the engine to stutter a little, or it might cause the AI to not expect things that are happening around it. Now I don't actually... Oh, I named it the in-game input handler. And we're going to say update tools. And we're calling the update tools every single frame, even though in actuality we have this if statement that says, if we haven't invalidated the tools, just return. Just skip all this processing we're about to do. Chakma asks, why do I write void as an argument for functions without arguments? He's probably referring to these two functions. And it's just so that I know that there's no mistake here, that these definitely don't take anything. Also, this keeps the compiler from having to do extra work. Granted, it's menial work that doesn't really do much, but even functions without any arguments whatsoever still have a void argument. Granted, you can't send it anything. It's not like a void pointer or, you know, any other kind of construct that's valid. But it's still an argument that exists within this function. You can even see actually that Visual Studio removes the void as well. It understands what's going on. It's just kind of a habit I picked up. The game engine uses that as well, and I got into the habit of it at school, and now it's just kind of what I do. It's more personal preference than anything else, but it lets me know that as I write these functions, I don't mean for anything to go into this, at least not unless I can really help it. So, oh, and this can be actually a nice, easy little thing here. Validate tools, true. Ta-da! Oh, and we need to initialize this at the very beginning. So nothing is invalidated. Cool. Nice, simple. Should do fine when all is said and done. Now, we have some other data we need to deal with, because obviously just calling update here is not going to be doing enough. We need to transfer over the logic that is currently sitting in each of these, and we need to transfer it over into here somehow. So right now we're doing all the heavy lifting inside this handle mouse event function. And we want to move it out. We want this stuff out of here. The question is, how do we do this? Also, I wonder if there's a way to pull the input, or if I just have to hang on to these as, like, here's what was done this frame, and then be able to pass that out. It seems like a little bit of overkill, and what I'm trying to ensure here is that even if I do a little extra work, that I'm not doing a ton of extra work and storing a ton of extra data. Because we want all of this to really take place somewhere else. But we don't want it to also consume extra CPU cycles because we want it to be somewhere else. This feature shouldn't really eat up a ton of performance. It's just one user interface call. So the first obvious thing we can do is we can, on every event, no matter what, we can take this and we can simply just invalidate the tools the moment this happens. Kevin asks, how do I do profiling? Most of the profiling I do is through the engine. It's very light, very simple stuff that just says, oh, controllers are taking this much time, and input's taking this much time, and rendering is taking this much. You may have seen it before. It's a little window that lives in the corner, and it's got a bunch of graphs that fly by, and it tells me frame rate and basic stuff. I don't do in-depth profiling unless the performance is abysmal, and I need to figure out what's causing something to take so long. Or the other reason I might do actual profiling and run profilers on my game is if I'm right about to release and I want to make sure there's nothing there's nothing else I can easily clean up to ensure that everyone has a good experience in the game. I did a fair hunk of profiling before I released my other games on the Xbox, but the Xbox is nice because every Xbox has very similar hardware, so I don't have to worry too much about, you know, people having different profiles of hardware and all that crazy stuff. It was a much more controlled environment there, so beautiful song from Bastion. I absolutely love it. So I need to find out how much information is widely available from the API. Because if we can get mouse position and details like that, we won't have to store it, and that might be nice. But I'm only seeing that deltas are available here, which isn't what we want. Not what we want at all. So at bare minimum, we need to store a new mouse position. Whoops, went too far. Let's see here. Alright. So we've got the mouse position, kind of the last valid mouse position. And anytime any mouse event happens, we should honestly just be storing this. Part of me wonders if there's a good way to just store this event data, but I have a bad feeling that it's going to get deleted after it's used, or that it's just something that's locally initialized, and the moment it's done being used, the engine just kind of throws it out. Ooh, although I didn't think about that. So the input manager might not have mouse position, but the interface manager might. It has a set cursor, but that's actually setting the cursor key itself. I'm not seeing what I need, which is fine. We shouldn't really do anything to work around how the game engine works. Things should just kind of settle in place. Oh. And this should be input handlers, mouse position is this, which is good. And then we invalidate the tools here. So the other thing, I really wish I could store a lot of this stuff. Especially stuff like this. You can see he uses his 4-character integer to kind of make notes on what has changed and what has happened. Because we need to handle each different kind of event, as well as the new mouse position that may or may not be somewhere. So one thought is that we could leave the input handler as is. Whenever you move the mouse, or click, or do anything else, this would continue to do its own thing. Not exactly sure how I feel about that. Oh right, I never figured out if this did what I wanted it to. Handle mouse events, yada yada. I'm hunting for where in the code he actually does the callbacks for everybody who has installed a mouse handler. Here's a handle event that has mouse event data inside of it. So we're getting close. Getting close. Reset mouse buttons. Handle mouse event. Here we go. Here we go. Okay, so some things you guys might not be able to figure out just from kind of glancing at this that I can see. For those who are unfamiliar with Windows style code, Windows has what's called a message pump attached to it, where Windows will send your application messages through the pump that have to do with your application in general. Like, this is not game specific, this is every Windows application ever. So when you click, it will send you a WM left button down message, or when you release that button, it will send you a different message. So every single message can get sent through the pump. And you can see that it uses Windows styles parameters here. So left param, wide param, even the unsigned integers are all completely capsed, and the window handle and all these are all Windows style pound defines that exist. So obviously we're looking at something that's getting called from the message pump. Not the end of the world, just something good to know. And you can see actually that when it calls handle window event, it just throws away the message. Like, some messages you really don't care about. For example, we could disable the little X in the upper right-hand corner by every time Windows sends us, hey, the user clicked on this, which is a WM close event, we can just completely ignore it. And that would stop the user from doing that. In fact, we could do crazy things like when you click on that X, it kills all the villagers in your town. Stuff like that. You can handle each message however you want, or you can let the window, the base standard window code, handle its own stuff. And you don't have to worry about it too much. And my music stopped, so let's fix that. Let's get a little Shadow of the Colossus in here. Also, lovely, lovely game. So the question becomes, you can see he creates the mouse event data as an instance, and then proceeds to fill it in afterwards. And so we can't keep a pointer, because the moment that this goes out of scope, this structure becomes invalid. We really don't want that. So So we have to figure out a good way to do this, because otherwise we're just kind of flailing in the dark. And I'd rather not flail too long. At least not in front of you guys on a stream. This is what I get for not planning much beforehand. I thought I would do some planning while I was at the dog park, and then there was some drama at dog park, and no fun. So I came home early and decided to stream early, and that leaves me without much of a plan of what I'm doing. Have I played and beaten FTL? Played it, yes. Beaten it, no. I refuse to turn down the difficulty, but I hate the difficulty cliff at the end, where you can be doing fantastically the entire game, and then the end boss just wrecks you, no matter what you have. You could just have a, bad set of equipment or crew members or something, and you just straight up lose the fight, and it's not your fault. Dog park drama is someone bringing their poorly trained dog and it acting aggressive towards other people's dogs. It's not fun. Kind of cuts my time short there. I'm protective of my puppy, so how it goes. Okay, so what I think I'm going to do in this case is we're not going to use this invalidate tools thing here. We're actually going to go so far as to move this functionality into a function that we can call from anywhere, and then we're simply going to have certain things trigger the tool to need to update. For example, let's see here. Let's take this first. So we're going to create a private function. Yeah, private function, and it's going to be called. Let's see. We've already got a handle mouse event function, so we don't want to call it that. But it would be like, man, handle mouse event's a good name though. Handle tool event. I could use the update tools as a good place to put all this, and then I could just call update tools. I could invalidate it and then update tools immediately after. Oh, the other thing we need to do is set invalidate tools back to false when we're done. You know what? Why don't... Is that a bad thing to do? I'm kind of bouncing back and forth, but it doesn't seem like a bad thing. We'll try it, and we'll see how we like it. So, I'm going to move all this mess right here to here. Let's make it return a Boolean for now, just to make our life a little easier. I don't want to have to modify and change too much, but I do want to at least keep some parity here. Okay, so I just copied and pasted code. Here's the update tools function. And this should return false. And what we're just going to do is say, return update tools. Okay. Is this going to work? Kind of. Definitely kind of. But it's expecting more data. It's expecting all this data to be here, when we may not have all that data. So it's easy enough for us to break out of certain things that we don't need anymore. For example, let me just clean up some of the stuff that's left behind. Right now it still wants the event data, because it wants to know what kind of event happened. DJ Beats, I work for OnLive currently. It's a cloud gaming system. I don't do game programming at work. I think that would validate some kind of like non-compete clause I have in my contract. I don't know. I'm not actually sure. I need to read that a little more closely at some point. But yeah, I work for a software engineering startup. So programming is my job. I do it for work, and then I come home and do it for funsies, because as people at work say, I'm crazy. And I do that kind of thing. Alright, so I'm going to pass in. We're just going to try something. And I'm going to keep pushing kind of the simple, change as little as possible approach, until it either starts to break down, or until this works the way I want it to. Good. People on Twitch should say I'm crazy. They'd be right. They would be definitely right. So, I have to move this inside my update tools function. But this won't work suddenly. So you're starting to, you might see what I'm running into, is even though I can call update tools from my own input function, I also have to call it from the game world. And the game world has no idea what may or may not actually be going on. But I can fool it. I can be cute. That's fine. We can do this. We'll call it an event type. So we're going to add this event type in to the update tools. And in most cases, what we're going to do is we're going to have a default argument in here whose type is kmouse moved? No. Oh, it's event mouse moved. There we go. So whenever I call it normally, it will only trigger code that makes the input handler act as if the mouse has been moved. And we'll only use this in cases when we don't have any other data to supply it. Let's see here, clean this up a little more. Is there any? Of course there's more stuff. There we go. Oh, there's more code here. Whoops. I don't know why. I kind of poked through and it's like, okay, is that everything? Yes. And then it turns out there's more code below. So when I call update tools here, we can actually pass it a valid event type. So we're setting our mouse position, and then we're saying, okay, we need to handle an event of the given type. But something's unhappy here, and it's going to show up in a second. Illegal call of non-static. Oops. input handler arrow. There we go. Must return a value. Sorry, let's try false. There we go. Okay. Yeah, C++ does have default parameter values. Something I learned very recently is that C# also not only has default parameter values, but also has named parameter values, which is a bizarre concept pulled from languages like Python, where you can actually say, I only want to specify these arguments, which is scary sometimes. But that's fine. And the other thing to know about C++ default arguments is when you set them, they have to be the last parameters in a function argument. Otherwise, you get a bunch of ambiguous function types, and you don't want those. So always make sure these are at the end. Alright, so we've got all the update tool stuff. And we're calling update tools here, and it should never do anything. It really shouldn't. Let's double check. In fact, I need to make sure that it'll even do what I expect it to do out here. So we're okay. We need to also input handler invalidate tools. Let's see. Is this? There we go. Function overloading is where you get into a gray area. I don't actually either. So it does one of two things. It either will, as far as I remember, it will either go with what the first. What is it? It goes with what the first function is. I mean, every single time, even when you overload, you need to have every single argument there. It will simply follow along with the original stuff, I think. And this is where I'm kind of hazy. I'm not actually certain. Oh gosh, that does fall into a gray area. I don't know. Huh. I'll have to look that up later. Now I'm curious. Yeah. I don't know. I can't quickly just, like, Google it. One thing I would suggest for anyone who's curious about all the dark, kind of interesting little corners of C++, there is a, there's a slide share called Deep C, and it essentially goes into all the reasons why things like this, why C does what it does and how it figures it out. And so I kind of assume that somewhere in there, that it would know. You can tell that other people have been Googling the same thing when Google kind of fills in what's going on. I'll just bring this across so you guys can see what I'm looking up. Essentially, the biggest problem is that when you generate default parameters, you create what's called an ambiguous function. So the function can have either one or two parameters. And when you overload it, you want to make sure you have the same number of parameters as well. And I don't know if it does any kind of automatic overloading as well. Function that uses default parameters can count as a function with different number of parameters, yada yada. So I'm gonna guess that the compiler should just complain if you do something bad. I have no doctorate. Despite the fact that my username is Dr. Mr. Waffles, I only have a bachelor's degree. Because I don't know. I looked at school and I decided not to go back. I have friends, lots of them, who went back and got their masters in game design. And when I compared their experiences to mine, I kind of think I got the better end of the deal, personally. I don't know. My ability to program seems to exceed those who stay in the academic field longer. Academic field doesn't really push the ability to code. They're just things you learn in the professional field that you do not learn in the academic field. Also, for those who want to know what kind of doctor I am, and yet haven't seen my sweater, let's see here. Maybe I can throw it on real quick. It is a little chilly anyway, so I may as well. Let's see here. Get this all put on. But yeah, this is the kind of doctor, right? Anyway. I actually don't know if you guys could see that. Let's see. Yeah, there we go. It's backwards, but you get the point. Alright. Yes, you guys can send links. I kind of went back on my previous statement. I did have a spammer come through and then kind of damage my enjoyment of chat. So try not to spam too many links, but yeah. You guys are cute. Alright, back to coding. Back to what I am here to do, and that is make the codes that run the games. Alright, so, the game world needs to do one more thing. We need to check if the camera is moving. So we check our navigation flags and make sure they're not equal to 0. And if they aren't, we need to, let's see, in-game input handler. That's when we want to do this invalidation tool run. So that should be all we need. If I've done this right, it will hopefully not crash. That is impressive, Deity, to actually... I have no idea how you did that. That's what I get for not lurking as much in other people's streams, is I sometimes wonder if I should. So, okay. Ah, look at that. It keeps with now. That is good. This is what we wanted. And let's see, can I also... Yeah, it also sticks around when I rotate. Good, 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 good. Alright. Bug fixed. Steam, go over here. In fact, Steam, why are you up? Let's see, what are people playing? Final Fantasy 14? Europa Universalis? Guild Wars 2? Nah. Nothing I'm too terribly interested in. Valiant Hearts? Alright, so... Whew, that looks like I've changed a lot. Let's make sure that I'm not actually mangling anything. It looks like I've moved this line and added another line here. Oh. Okay. Did I not? I don't think I committed my, Oh, I didn't. I didn't commit the visibility code at the end of the day. Oops. Oh my gosh. I should have done that. So this is going to end up... I guess this will end up going in one giant hunk, but oops. Is a really good way to put that. I don't like committing more than one feature per commit, if only because it's easy then to single out where that feature is in your SVN, and then kind of pluck out the code that breaks things if something goes wrong. In this case, this is a double feature commit. Not the end of the world. Basic commented out. Visibility starter code for the Fog of War. What else? What else? Oh, of course, we've also got the stuff we just added. Fixes... Actually, this is just a single feature commit. So this is a bug fix, bug fucks. Ooh, I shouldn't say that word. I just kind of said things without talking. Are you kidding? Real men use floppy disks, right? No danger in that at all. So fixes problems with camera movement not updating tool. There we go. Alright. Bump. I'm actually just gonna say this at the beginning is better. Alright. All done. Cool. So, now that I've spent far too long doing things that I'm not sure should have taken me so long. Bring up my to-do list here. Dump this onto our done list. Come on, you. So I could start doing pathing. Yeah, exactly. 1.44 megabytes. I remember when that used to be a ton of space. Of course, now I've got a 3 terabyte network drive attached that's full of, oh gosh, TV show, like more content than I can ever consume is sitting on that drive right now. Alright. Hunger might be worth it. Also, wandering might be worth it. It also might be worth it to start in on... I'm just trying to think of gameplay features that would push this game further out and make it more game-like. Because we're not going to make this a game overnight, right? We're going to keep adding features until it's this nice feature-rich toy. And then we are going to start adding conflict on top of it. Because the biggest thing in this case is that we want to make sure that the game itself is fun and that the conflict does little more than add tension. Because we don't want the conflict to be the only interesting thing about this game. If the conflict is all that's interesting, you end up kind of with the boring part of the game and the fun part of the game, and they don't ever really mesh. We want the two to kind of mesh pretty well so that... you know, the game never has a terribly boring moment. You might have tension-based lows and highs, such as what the Left 4 Dead, the level director tries to create. But you never want to end up with something where it's constant high tension or constant low tension, or like a variable, you know, ping-pong course of the two. You want something that ramps up and then ramps back down. Excuse me. Global illumination and real raycasted lighting. That's way too much. Granted, the engine does have kind of a fake global illumination system called a radiosity space, but that's a lot better when you're doing things like pre-created scenes. Dog, what are you barking at? What are you barking at, puppy? They're just little wolves, too. They're not full-on barking. Let's see. So what would make this a more full game, or a more, I should say, a more interesting toy for now? I as a game designer, I actually use the terms meaningfully, where a game is essentially something that has conflict and you know, there's tension changes or a story that's told, versus a toy is something, it's interactive, but it's not something that leads you along on any kind of journey. There's no end point with a toy. A toy is just something you do stuff with. Like, Banished is a great example of a toy. There's no end. Nothing tries to kill you. Minecraft is another good example of a toy. Or, I'm trying to think of other really good examples of toys that people call games, but they aren't. Minecraft is really the biggest toy. It's not technically a game. Yeah, things try and kill you, but there's no even with the Ender stuff, there's not a ton of real progression in terms of Minecraft as a game. Alright, Kerbal Space Program is a fantastic toy because it teaches you friggin' rocket science. How many games can kind of go that far, right? I would love to learn me some rocket surgery. Like, that would be a great, Kerbal Space Program. If I had more time to play that constantly, I would play the heck out of that game. I've seen people who actually will look up NASA procedures on how to do things like moon landings and then proceed to attempt to actually replicate those in Kerbal Space Program. Because you do need to do the same thing. They've got the same... sorry, I say rocket surgery because it's a joke I use constantly. When people say something is not difficult, usually you say, oh, it's not rocket science. But rocket science is actually notoriously easy in some ways. Like, the science itself is easy. The actual obvious implementation is where it gets difficult. So yeah, as I Am Deity is mentioning, it's a mixture of... you say, oh, that's not rocket. Instead of saying, that's not brain surgery or that's not rocket science, you say, that's not rocket surgery or that's not brain science. My humor, ha ha ha, I don't know. It's something I find funny. Kind of want to do water, but kind of don't, because that's a frightening prospect. Also, water doesn't really, it's pretty, but it doesn't add much to the game. So let's not jump into that. I kind of like combat in some ways. But that, once again, we're jumping into making it a game suddenly. Although, I guess we could start with combat, maybe. Although, for combat to work, we need pathfinding in most cases. Unless we want people to be able to just, like, climb cliffs and giant valleys in one leap while fighting each other. Idle wandering? That's prettier than anything else. Oh gosh, so many choices, so little to kind of really decide on. This should be a simple decision. Let's see, just reading through chat. The distant settlements further out would be nice if I could have larger terrain, but that's still buggy. In fact, I'm going to go so far. Is my partner online? Of course he's not. Last online 14 hours ago. Oof. So he'll be online soon. He usually wakes up at about now. In the next like 15-20 minutes he'll probably wake up, do his shower morning routine. And when he comes on Steam, I might take a moment to say hi and let him know that such bugs exist. Because that's a giant pain in the arse. Okay, so one thing I do want to do. I am going to go to a website that I use very frequently, called Open Game Art. And usually what I do, and I don't do this too often, but I'll flip through kind of the newest stuff that's been added into the engine, so that I can find anything, because these are all open source art assets, so I can find things that I can use in the game without paying somebody. Because the less work I have to do in order to make this game, and the less money I have to pay out, the better this is for me. Because I can have quality graphics without then, going out and doing all the crazy pixel art and stuff that I really need to do. And no, Kevin, he is not Australian. He's just on a really, really funky sleep schedule. And he does this to himself, honestly. Yeah, there's some weird stuff in here that most of it you just kind of ignore. But every once in a while you're like, oh, that looks useful. For example, okay, maybe not a giant robot reaching for things, or... So the stuff I have grabbed so far, I mean, it's simple, it's cute, and if it's got, if it's a full sprite sheet set, that might be worth it. To grab one of the... Oh god, it's too derpy. No, it's too derpy, I can't do it. This one, though, this one might be worth it. To have, like, here's a basic enemy, so I don't have to spend time doing crappy programmer art that's going to get torn out anyway. And that is an interesting pixel pack. I also tend to look at things in terms of what I might be able to use during the next Game Jam, because that's coming up. January 23rd, a week and 2 days, I'm going to start this stream and either not turn it off for 48 hours, or I'm going to leave it on, and you'll just see, like, I'll be right back whenever I decide to wake up. Right? Something like that. Because that's a 48-hour game jam, and guess what? I'll be here for it. All 48 hours of it. Or at least as much as I can manage. So I'm not really seeing anything awesome and new. Not Ludum, Global Game Jam. Very different. At least, I don't know. It's different enough in my mind. Maybe I shouldn't say it's terribly different, because Ludum is definitely a great contest. And by the way, what we're talking about, for those who don't, for the uninitiated, once a year, there's the Global Game Jam, which is a 48-hour game-making extravaganza. You sit down for 48 hours with a team of X other people, and you create a game. Ludum Dare is very similar. You have a contest or a competition where every X amount of time you then proceed to make a game under whatever theme they come up with. So last year I think our theme was the sound of a beating heart, I think. That might have been last year's. It honestly was not the greatest theme ever. They've had some really good ones in the past. Deception is a fantastic theme. Another one was Extinction. Saw a lot of frickin' zombie games come out of that one. I would go so far as to say too many zombie games, because zombie games as they are already a kind of burnt out genre for me. Maybe not for everybody, but for me, I've seen enough zombies for a lifetime. Zombies, Nazis, insert, something you don't have to work hard on the AI on, and they're enemies that just kind of everyone hates by default, right? I'm going to try and look up. So, as nice as that is, what the heck is this? Mind sprites for my RTS. Okay. Dang it, somewhere here. First off, I know it's in the 2D art section, so blah. Man, I wish I remembered the name of it. It is probably sitting in my download folder. Micro characters. There we go. And please do not mind the possibly pirated things you saw in there. Possibly. I'm not admitting to anything. Will that hunt me what I need? Surprisingly not. Let's turn everything back on. One of these searches, there's a micro character base here somewhere. Unless they removed it from the site, which would be unfortunate. Really? Am I unable to find the art that I have grabbed earlier and possibly can no longer find? That would be a heck of a thing. That would really be a heck of a thing. Granted, I guess it might mean that I might need to finally find an artist. Oh, there we go. I have a link to it still. Haha, ta-da! Watch, it's not here anymore. I'm gonna get a 404 or something, which would be hilarious. So, I'm kind of looking at combat. I'm also looking at this mission system, because I've got some time tonight before I have to be anywhere or do anything. There we go. Stuff done by this artist. I like it because he's got some other things in here that aren't people, right? I've got the bald human, but he's got like trolls and orcs and undead and things. And I could use those as good bad guys to throw in. Let's see, do we have anything else No, just overworld stuff that he's done. Although, we might want overworld stuff at some point. And this is kind of neat. I kind of like the style. We might want overworld stuff at some point, because the player should be able to bring up a map, kind of a top-down map that shows where things are. And that'll be something that I'll need to work on in the future. Okay. Let's start in on Pathfinding and see kind of how far we can get. Right? Good old A-star, and specifically creating the system that will generate a kind of that will create our nodes that we can link together. Because we need to find a way to store the pathfinding data before we can even start to think about doing things like going so far as to run A-star on that graph. We need the graph, but we need to find a good way to store things first. So the most obvious thing I can think of is that pathfinding data should probably live in the game world. It just kind of makes the most sense. The question becomes, how can we best represent this data so that we don't end up doing tons of extra work like I did last time? Because anyone who saw me try and work on trees the first time around and watched me fight with and kind of subsequently almost fail for a while. I actually did fail for a while. To organize it correctly, that was the big reason I had trouble that first run through. Was because the trees weren't organized correctly, and because they were organized poorly, I then proceeded to write poor code to try and manage that poor organization. And we can do better than that. Especially on a first pass, we should be able to do something better than that. So we've already got these cells, and we already know how they're hooked together. We have a cell graph, and the cell graph goes as far as to have cells and edges and vertices and such. I'm actually going to pull over a web browser for a second just to look at. I know I'm probably not going to do such a crazy rewrite, but he has graph and other element users that it might make sense to at least get a good understanding of how he's doing this, so we can either use it ourselves or so we can implement something similar eventually. So you can see it's a templated class, and you have an element type and an edge type, which is friggin' amazing. I actually really love how this stuff is portrayed. Start and finish elements, next and previous edge. Like, this is all done very, very well. To the point where I'm actually tempted to replace this current graph structure we have with the in-engine graph stuff. Maybe not right now, because that would be more needless refactoring. Yes, it might drop the amount of code, but it doesn't add anything for us. The code we have is written and working, and we're likely to break things, and also I don't see what it affords us. As lovely as it is, it doesn't gain us enough for me to care right now. It's nice to know, though. Nice to know that this graph object exists. And we might actually even be able to use it for the pathfinding graph, if at the very least we don't like how some of this works. So we've got the cell graph, which is nice. So we could put the information inside the cell graph, because it already holds a lot of what we need. It's got the edges, and it's already got all the cells. So we don't exactly need to add a ton. In fact, it's already got a bunch of helper functions as well that kind of do what we want it to do. We might just be able to go so far as to add something to a cell edge. So where is that? Vertex. Where the heck is cell edge? Did I pass it? I passed it. Okay. So we might go so far as to just say whether or not this is a pathable edge. So that would allow us to then say, turn off certain edges where the height difference is too crazy, and people wouldn't be able to walk up and down those. Is that the best way to do this? Maybe. Definitely maybe. I'm trying to think if there would be a better way or a better place to put this information. But the edge seems kind of like the best storable way to do this. Granted, so there is one big downside here to doing something like this. Yes, we could pre-compute whether an edge is pathable or not by entities. That changes how we have to think about the game. We can no longer have different entities pathfind around the world in different ways. So that's kind of why I don't like this. In fact, we might even just want... let's see here. It'd be a list of 3D points, and that would be our path from point A to point B. And we would just have, like, find path. Okay, music's still going. We still actually have a lot of time. Start and end. And this is const, because this doesn't change anything. Oh, we need one more thing in here. The max height change. So this would be kind of a good way to start in on A star. Because honestly, I'm looking at this and all the information is where we want it to be. It might not be in the most easily readable format, but it's also not in the worst format I've ever seen. I've had to deal with worse, which is a frightening thing, I might add. Granted, those were in, like, in-house scripting engines, and no, I don't like it. But I think this might be a good way to do this. So let's start in and just write ourselves some A star. Good ol' A star. I looked around, I did a little research before I did actually start this, if only to see what existed in the world and if anything has changed since then. Eventually I might upgrade from A star to D star, because it's a little more directed and allows you to have better control over the way that dynamic objects are handled in a scene. Or handled by pathfinding, I should say. But for now, we're going to go with good old A star. And you guys are going to watch me cheat on this one. I don't do this too terribly often. I like to write my own code. But sometimes you've just done something so many times, you don't really want to do it again. For those who are wondering what A star is, it's essentially a mixture between breadth and depth first search that allows you to find paths with the best path to a point, or not a best path, but a good enough path to from a point to a point without searching the entire tree. Because if you search the entire tree, it might take forever. Especially in certain games where it's like, you don't really want, in Minecraft, to search the entire tree. And what you may or may not see is a friend of mine asking me if I want enchiladas. Do I want enchiladas for dinner? It's all-you-can-eat enchiladas. I do like all-you-can-eat enchiladas. One of these I've used before. Dang it. One of these sites I've used before, and the site essentially has a pseudocode that I've pretty much used every single time, because when somebody's written the algorithm for you, you don't really want to rewrite the whole darn thing. Hey, a newer version of this. Ooh. Whoa. Okay. Oh, okay, so for someone who wants to see how A star works, you can kind of see... Actually, I'll just start the animation. You can kind of see how it's, like, searching the entire grid. Now, granted, there's no endpoint here. In fact, it looks like it's doing a variation of A star, which is not really what I'm hunting for right now. There seems to be a little bit too much going on here. The idea is that you want to early exit. That's the whole point of A star. So without early exiting, you can see that this guy has searched this entire graph, and you can see the distance that it's gone, and every single cell has been traversed. That takes a lot of time, especially in games with lots of terrain like what I'm hoping to create. You don't really want to do something like that. What you want to do is something like this, where you can see something even smarter is probably possible here, but you can see that it starts to move. Oh, cool, these are interactive. Okay, you can see how it starts to move in the right direction, and then kind of proceeds to follow that direction, and the most that it ever traverses is kind of everything in this area around it. In fact, A star is smarter than this. I don't quite understand why they're doing something like this. It seems a little bizarre, but it's not the end of the world. So this is something more like what we'll be doing. You can kind of see they have their various cells, and the movement distances between cells is what will be giving us our kind of best path possible. Is this their A star? This isn't what I usually use, though. Let's see if we can find somebody who's just, like, pseudo-coded it stupidly easily. Because, oh, here we go. Wikipedia. You will have the pseudocode I want. Yes, of course they do. Of course they do. Of course they do. I want enchiladas? Yeah, kinda do. Kinda don't, though. Kinda want to keep programming. I don't know. I'm a sucker for just skipping meals accidentally when it comes to food like that. Do I want enchiladas? Because it also means I'd have to leave and come back. And I hate to leave you guys so much. It just brings tears to my eyes every time. I love you guys, but not that much. Enchiladas. It's a good sign when this is one of the most difficult decisions you have to make in a day. What do I want for dinner? Enchiladas? I could do that. I'd also be down for... maybe I could do the fajitas. We usually go to a Mexican restaurant because it's all you can eat enchiladas on Wednesdays. And of course they have Taco Tuesdays and all kinds of things to make me fat. I, of course, say that, and I'm, you know, skinny as a stick, but whatever. Do I want enchiladas? Not really. Not really. Not really feeling enchiladas tonight, actually. Alright, so let's start in on this. We've got our start, we've got our goal. Now, what the code has as start and goal are different from what A star wants as start and goal. Ooh, I am so sorry. Melted popcorn is no fun. Really, really isn't. I hate melted popcorn. Or not melted, but I should say burnt popcorn. That is a terrible smell. So we have our start cell. And we can very easily just get cell. Right? Yeah. We get cell, and we use start. And we're going to get the point 2D. And for some reason this... Oh, I know what's wrong. Ha ha! Let's do that. Let's actually put the... Let's see, can I close... Yeah, let's make this a little easier for me to flip through as well. Oh gosh. I love how Wikipedia's code doesn't actually crunch down when you do something like this. All the text does, but the code doesn't. I wonder if it's some special formatting thing that just kind of keeps it in place. That's actually kind of frightening. Because it looks like it should take up a good amount of space. Oh well. We'll see how we can do with the window as is. In fact, I might even do... Ah, there we go. That'll give us a little more room. We don't need the file list open right now. Does getCell not have a 2D? Yeah, it does. What are you talking about? Cell graph, you so crazy. And for now, just to quiet it down. Actually, no, we're doing this right. Point 3D. This is going to be our path list, and we can't just actually return. Can we? We can, but it would be ugly. So I don't want to just return this this giant array of things. We actually want to return a pointer to the array of things. Now, this comes as a dangerous thing, because for us, if we return a pointer, you're not sure if that pointer is something that needs to be deleted afterwards. And honestly, it does. It should get deleted afterwards. It might be worth it to try either passing a reference across, or what I like better, actually, is not returning a darn thing, but instead having, at the end of this whole thing, a reference to an array. That's nice and simple. Oh, of course I need to update my function to have what I need. So at the end of this, we put this in here. There we go. And now we don't have to return a darn thing. And let's see if it... Of course I didn't think about this too closely. The compiler, of course, the compiler errors are going to be split between my screens, which makes it really difficult to read. No instance of overloaded function matches the argument types. Really? It doesn't? That's bizarre. Because you return a constant reference, and you use a constant reference. So what's going on here, code? Why are you unhappy? What have I done? It looks like it's going to have the same problem. This getCell function is unhappy. No instance of overloaded function matches the argument list and object. Oh, okay, it doesn't, and object argument types are a constant point 2D. I wonder if I can't send that across as a reference? That'd be bizarre. Let's see here. No, this is a constant reference. What are you doing, code? Why are you being so weird? I call getCell. And getCell has those. And this is a point 2D. Let's just try something real quick. Okay, this definitely should work. Cell graph find path. And getCell is non-static. Guys, what am I missing? I'm being completely dense and missing something. Something stupidly obvious, too, that I'm just not... I'm not getting, and I can't tell you why. Oh. Ta-da! When you call getCell, that is a const function, and we are inside findPath, which is also a const function, right? we can't call non-constant functions from inside a constant function. Okay, there we go. Whew! I was wondering what I was doing wrong. I felt like an idiot for a bit. I just kind of... Oh man, sometimes that kind of moment of unknowing comes over you, and you wonder what the heck you're missing, and it's sitting right in front of you, but because your screen, or monitor, is only so large, things kind of fall off the end here and cause you to miss stuff. That would definitely make a much... There should be a better compiler warning for it. Compilers are notorious for having bad errors and even worse warnings. And nightmarish linker errors. Oh my gosh, don't get me started on trying to figure out what the heck a linker error means. It just doesn't even... Those don't even compute. They definitely aren't English. And to make it worse, they definitely aren't terribly helpful in that respect either. They're just so terribly frightening. So, we're going to do a few things. We are going to take our path array and clear it out. And we're going to do some simple null checks here, because we want to make sure that if you try and navigate off the edge of the map, that we catch that case and deal with it somehow. We don't want to deal with it in a terribly stupid way, but we also don't want to put too much work into it, because it's not a case that should be happening too much, so we don't need a ton of code here. So what I'm going to do is I'm actually just going to say, let's see, add element, I think adds elements to the end. So if you tell us to go somewhere and we don't know how to get there, we're just going to add the start and end point to the graph and just kind of let you go. Eventually I might make this smarter. And I'll even put in a little to-do here for myself that just says, find path to closest cell, then travel straight to endpoint. Because that would be a smarter solution. Right now, if you say, I want to go from the center to off the map, you're gonna go in a straight line and that's it. Not the end of the world, but it might be better for us to kind of have you navigate your way there and then eventually say, oh, okay. Because this is a good way, actually, now that I think about it, this is a good way, if you could directly control units, to glitch somebody into a part of the terrain that they might not otherwise be able to reach. Just saying. The hacks already exist. This is how you create backdoors for things. Alright, so let's just use cell pointers. Do we use cell pointers for our... yeah, why not? So our array of cell pointers, we need one called the closed set. And I'll kind of be slowly talking through this, even though A* is kind of a well-known and very easy to find documentation for kind of thing. You still, I'll just talk through it kind of as I go. So we have the closed set and the open set. And the idea is that the closed set lets us know where we've already been. So that if you have 4 nodes that all link to each other in a cycle, you don't end up cycling through them infinitely. You will eventually go, I've been here, now I've been here, now I've been here, now I've been here, and you'll look back at that original node and say, I've been there already. No need for me to try again. So, in the open set, can we do this? I wonder if it'll let me do this. I don't actually think it has default initializers, but I figure I'll try. No, it doesn't have a default initializer, of course. That's fine. We just do this the old-fashioned way. Say open set, add element, our start cell. And so the idea is that things start in the open list, and we will begin to populate the open list with possible paths as we find them. So we're going to start traveling in the direction of our endpoint, but we're not going to know if each of these paths is complete until we find a complete path that actually leads to our endpoint, to our destination. Here's where things get a little crazy. I might need to generate some kind of So I want to generate some kind of data set that essentially says, how do we do this? How do we generate this data set correctly? Okay, I got it. So we're going to create more arrays. Arrays of arrays of arrays, right? And here's going to be our parent array. And we're just arrays and arrays and arrays. There's lots of data that's going to be flying around inside of this function. And it's not going to be the end of the world that we have all this data, because this is all temporary data. But this is all needed, at least in the short term, until we can clean it up a little bit, so that we can kind of have all the information in one place and then remove what we don't need as we go. All right. Some things that I'm currently... So the reason I'm using an array, and maybe I shouldn't, let me think about this for a moment. I know I have a fixed number of objects, but not every object is going to get placed in the array. Don't like arrays. At least not the engine-based arrays. I think I'm going to actually swap myself down to standard arrays. If only because... Whoops, didn't mean to do that, though. Because this is a lot of information flying around. And while, yes, we can save ourselves some potential time and space by doing this cleverly, it also will cause us a lot of trouble if things start to go wrong. Kind of like the same way I had trouble with the tree bundling before. I want to make sure I don't have that same problem here. There we go. And we need a number of elements equal to the total number of cells. So we should have a cell count somewhere here. Somewhere inside the cell graph. Probably this cell array count. Get element count. There we go. And I'm just going to move this into here, because that's not a number that's ever going to change. Exploding mushroom, I really want to avoid having any kind of micromanagement in this game. I'm going for more of a micromanagement-free system, if I can. I might want to do something simple like movement for the case of having a good test case for finding paths from one point to another. But I definitely don't want to have that micromanagement as part of the final game. Too many RTSs go down that road, and I definitely don't want to be going down that road myself. Let's see here. So we have our standard G-score and F-score, parent array, all that good stuff. Also, let's see here. The G-score of our current starting cell, which I'm using indexes for all of this. So this is why I swapped over to using giant freaking arrays, is that, of actual, like, C-style arrays, is because now we have all the elements initialized for us, and we don't have to worry about adding or removing things from the array. All we have to worry about is managing the data correctly and then deleting it when we're done. Because we are calling new, so at the end of this whole thing, we do need to ensure that for every new, we call delete. And also, because we're calling new and creating arrays, we call the array delete. There we go. Just a little code cleanup at the very end will keep us from tearing our hair out later, wondering why we're running out of memory within seconds of the game starting. Alright, there's also some other stuff to quickly note here. We could also do one more check here and say if the start cell equals the end cell. That is another good reason to not do any of this processing, right? Because if you're in the same cell as your endpoint, you know you have a clear line between the 2 points. So just friggin' walk there. Not the end of the world. Alright. So we have our G-score set. We also have to set our F-score. And we're going to need to come up with a little function that can do essentially a cost analysis of how far it would take you to walk from one point to another. In our case, we're just going to... Actually, let's just write that now. I'll just call this, like, my distance heuristic. Big, fancy terms. Essentially what this does, it's going to be the simplest thing I've written in terms of actual pathfinding code, but all it does is it gives us the distance between 2 points. And actually, let's go a little further with this and make sure that we're only calculating the distance between not just 2 points, but the 2D distance between 2 points. Because right now, it doesn't cost a unit anything to walk up, right? Right now, they just kind of teleport upwards. So for now, we're going to make our distance heuristic match that. You know what? Actually, no, that seems like a bad idea. I keep bouncing back and forth. I might end up putting it back in later again. But the big thing here is that we can say, first off, I need to set that to 0. Also, I need to set this to the distance heuristic between the start and the end. So essentially what we're going to do is we're going to track technically 3 numbers, but more like 2. We're going to track how much it currently costs for this possible path. And we're going to kind of guess at how much it'll cost to complete that path. For example, if I want to walk from point A to point B, I'm going to guess that at bare minimum, the distance from A to B is this straight line, and that maybe I can just walk in a straight line. And then as it turns out, if I end up taking this long route around, I'm going to keep that in mind so I can always come back to the shortest actual path that I've found and say, well, it'd be nice if I find this straight line, but that's a best case. So maybe I will actually end up finding this somewhat longer distance between 2 points. Okay, while, whoops, that's not how you spell while. While the open set element count is greater than 0. Let's see here. So, while the open set is not empty, we need to get a current cell. And of course, I see my leet speak still works. I typed in cell like this instead of as I should have in English. Just testing out the leet speak, making sure it still exists. Or that it still works for me. So, So now we need to go through and we need to figure out who is the closest point to the end. So we're going to have this possible path that we're constructing the entire time. And each possible path, we need to see who of all these paths is the closest to the endpoint to know which one to continue with. If the endpoint's over here, and this is one of our possible paths, we want to pick this one before exploring any of these, because these are much further away. So we want to try and find the closest and shortest path between these 2 points. So for cell pointer current equals open set 0, int I equals 1, I is less than open set dot element count. So I'm just looking through this open set and I'm trying to find the closest one. I need a float that's the closest distance. There we go. Okay, so we have this open set. Cell pointer. Possible current is the open set I. And we're just going to look at these basic distances between the two and see who's closer. So if the distance heuristic from, let's see here, and we need to make sure we're using the full distance here. So if, let's see here, if the g-score of the possible current plus the distance heuristic from, this is where things get a little crazy, possible current origin to the end, if that distance is less than, and here's where I'm kind of frightened of using something like this. I don't want to be alt-tabbing all the time, but I want to know how long I can make my lines before I start to lose anything. And I can kind of shorten this a little bit and still be able to understand what's going on. I can do that. That's not so bad. I'll just alt-tab back and forth and warn you guys now. Epilepsy warning, right? This might happen. Not really. It probably won't. I think epilepsy is only triggered by colors changing rapidly, and I definitely won't be alt-tabbing fast enough to trigger anything like that. So if the f-score do I actually store this? You know what? For now, I'll actually use the stored value. Oh, but we haven't... Oh, okay. Let's look at this real quick before we figure this out. The f-score is only generated for the start value. We then get the... Okay, but if it's in the open set, it will definitely have an f-score. Got it. So if the f-score is less than the closest distance... And actually, we don't even need this closest distance, do we? All we need is also the f-score of the actual current, whose index is there, and we just compare. Simple as that. If our f-score is less than the others, then current equals possible current. Ta-da! Okay, so now we've got who is the closest answered. So we've got this line done. And in fact, I'm even going to go so far as to like empty set I'm going to grab some of this and just copy and paste it into places so you can kind of understand where each part is coming from. So the pseudocode will live alongside the other stuff. In fact, why don't we just do that for everything? Duh. Oh gosh. There we go. This is much easier. I don't have to Alt-Tab back and forth or any of that garbage. Oh, so much nicer. So much nicer. I like doing this. Whoops. There we go. And if you guys have any questions, please feel free to ask. This part is, I won't call it mind-numbingly boring, but it can be pretty bad. Just how boring this can be. Oh, this return failure should actually be outside of this. Now granted, we can't actually return failure. We've already checked. Oh, no, we actually can. We need to keep this in mind for later, so I'll just leave that there. But yeah, this isn't mind-numbingly boring, but it definitely can be one of the less interesting parts to code. And I'll keep talking as I go along, but I'm more than happy to also answer questions and such. So if the current and the end cell, is that what I'm calling it? Yeah, if these two are the same, we now need to break out of the final. Actually, no, we don't. We need to... I don't know why I keep doing this. Let's put this here. And then, for now, I'm going to leave reconstructing the path until afterwards. Just because that's kind of its own step that's nice to do separately. Otherwise, openset.remove element. Oh, we need the index of the element we're currently removing. That's unfortunate, because I don't have a really... Can we find an element? Yeah. Okay. Openset.remove element, openset.find element. We're being a little lazy here, but it's not the end of the world. So, okay. Remove current from openset. Done. Add the current to the closed set. Also easy. So Extreme Gamist asks, do you suggest using engines like Unity, or should I really make the entire thing myself? Do not make the entire thing yourself. Please save yourself the pain and the effort and the number of unfinished projects. Use somebody's engine pretty much as soon as you're willing to make something large enough that it warrants an engine. For example, if you're making Pong, you don't need Unity to make Pong. Granted, if you're trying to learn how Unity works, making Pong in Unity is a good example. But you use engines because they are tools, because it's a lot of code that you could write yourself, but somebody else has already not only written it, but bug tested it and cleaned it. Something like Unity is a fantastic tool. And if you want to make a game and you don't want to make an engine, use something like Unity, or, you know, I wanted to make a game that had a good user interface system. So I used an engine that had a good user interface system. And I am profiting quite a bit already because of that. So really my biggest thing when it comes to whether you use or make an engine is it comes down to your needs versus the actual needs of the game. So if you say, I want to make a game that does all this cool stuff, can you find an engine that will let you do that stuff? Or do you end up needing to make your own engine because there isn't an engine that supports quantum time traveling code. Like, stuff like that, you probably want your own engine for. But if you're doing something that, you know, has basic needs, you can make a lot of stuff in Unity. Unity is a fantastically powerful tool. I find it a little messy at times, and I may complain about it at times, but I still think it's a great tool. So definitely, you know, go for the engine. Especially if you're at a point where you understand what's going on, then you definitely don't even need to make your own engine. Making your own engine is fantastic for learning, but it's a pain. It is very difficult. Let's see. 4 int equals 0. 0. Come on, 0. There we go. I is less than the current engine indices dot get element count. There we go. And I'm just going to put this close out here. Yeah, no problem. I mean, I'm happy to answer questions, as I said. Not only does it make this go by a little faster, but also you guys can kind of get more education or more entertainment out of this stream and kind of feel like you got what you need out of it. So right now what I'm going through is you traverse to the next cell, and then you proceed to look at all the neighbors and add them to the open set. Because if they are possible paths, then you have to figure out, okay, if I can walk through this one, should I? If our endpoint's over here, yes, we're adding these guys as all possible next points, but we're only going to really explore the ones that are closer to the endpoint. So these guys here are probably the only ones who are going to get further explored. The reason you add all of them, instead of just the ones you're probably going to go for, is if there's a big wall over here between you and the endpoint, you might actually end up going all the way around to get there. So they have to be there eventually, but you're going to end up doing a lot more work as well. Okay, so we're going to do a few things. First, we're going to say if the neighbor's in the closed set. If find element current edge indices I dot arrow? No, dot, definitely dot. And this holds integers. Okay. Right, cuz, oh my gosh. And this is where a system like this breaks down a little. We have to go into the edge array. Array has 2. There we go. The edge array dot. Oh gosh. This is okay. Int neighbor index. Let's break this up into a few steps, just so we don't lose our minds trying to get this done. Also, we need the cell edge to be here. So, Extreme Gamist, I am currently making an RTS survival simulator, where it's not so much StarCraft, where it's you versus your opponent, but it's you with your settlement trying to survive the world as it attacks you. So think, I've been using this a lot, but think Banished, if you've ever played it, or SimCity, in terms of you have the city building, but it's also post-apocalyptic. So the landscape is part of what's trying to kill you. The lack of resources is trying to kill you. Eventually there will be monsters and other settlements who are unhappy with you, who are trying to kill you. So that's kind of the gist of what I'm going for at this point. Let's see here. So we have our cell edge, and we need to pull that out of the edge array using the current edge indices I. So now we have the edge. Then we say, okay, the neighbor index is equal to if this cell index is equal to our current cell, our current cell's index, then it's the other cell's index. Otherwise, it's the first cell's index. It's a little messy, but we get what we need eventually. So we check if our neighbor index, and what does find element return when it doesn't find it? Probably -1, right? That's probably the smartest thing to ever do. If you call find element, if no match is found, then the return value is -1. Fantastic. So if it's greater than or equal to 0, so if it's a valid number pretty much. Oh, and we need to make sure, here's the other thing, cell array neighbor index. And this is going to want to return an instance. We need to actually return a pointer. So if that's greater than or equal to 0, then we need to continue. And we don't need comments that say the same thing, right? That's a little redundant. Do I plan to publish this to larger platforms in the future? I don't quite understand what you mean by larger platforms. I'm assuming you mean maybe consoles. For now, I'm planning for at least a standard PC, Mac, and probably just PC and Mac release. I don't know if I'll go for Linux, but maybe. Linux is always kind of a scary area to dive into, specifically for someone like me who has so little experience with it. And obviously, if I can pull this off with like a PS4 or an Xbox One or a 360, I'd be more than happy to. As much experience as I have with a PS3, I definitely don't want to code on one of those monsters. I love them to death, but not a huge fan of it in terms of actually ease to code on. So we're going to use the G-score. Actually, I kind of like their variable names for G-score and F-score and such. So I'm going to swap to that. It just looks cleaner. So let's do that. I'm all one for trying to keep things as clean as possible. Plus the distance heuristic between the current and the neighbor. Okay, so we need to say current origin and then the crud. Cell pointer equals, let's see here. I dig out the index, cell array neighbor index. There we go. And we can clean this up a little. And we can also do neighbor.origin. And now you'll notice this actually goes off the top, so I'm going to just move this above. I don't like having things that are wider than my screen. Granted, that's very, very arbitrary, right? That's really a kind of a bad arbitrary to have, but it's not the end of the world. I don't actually care a ton. It's just me and one other person coding, and if my lines of code don't really fly off the edge, it should be fine. So I'm actually even going to go so far as to convert this to a pointer earlier, because I see a bunch of places where I'm going to want the pointer instead of the instance. That's fine. If the neighbor, if the open set so if The neighbor's not in the open set. So this is if the neighbor is in the open set. If the neighbor isn't in the open set, less than 0, because remember, it returns that -1 if the neighbor is not found. Let's see here. Here's our parent array. Did I really name it like that? Yeah, I did. Okay. Yeah, eventually I'll have something playable and interesting and fun to play, and that's when I want to dive in and actually have you guys be able to do things like, you know, download demo copies and be able to play what little I've made. I might make that available only to subscribers or only to certain, you know, groups of people, depending on how I want to do that. But essentially for now, the big thing is that I'm just trying to make something for now, and then I will dive into, okay, I've got something playable. How do I not only do something like an early access system for it, like what Steam has, but also how do I start getting you guys in on the process without just simply handing it to everybody? And I might hand it to everybody. That might not be the worst thing in the world. But still, it's something I want to keep in mind. So we're setting the parent array. So the parent array, what it does, you have your current node that you're at, and you have a link back to where you came from. And what we're doing is we're keeping a path backwards of where we've been, kind of a breadcrumb trail, so that when we finally do find our way to the end point, we can follow those breadcrumbs back again, so we know what our original path looks like. That's kind of the whole point of A star, is you find a path as fast as you can, and then you run backwards along it to your endpoint to make sure that your endpoint is what you expect it to be. And so also so that you have this good breadcrumb trail backwards. Okay, something I just noticed, and I'm going to bring up the A star again. We're doing this calculation, but it doesn't actually look like we use this calculation anywhere. Oh no, we use it right here, and this is something I've missed. I missed this OR statement right here. So this OR, the tentative G-score, is less than the G-score of the neighbor. There we go. So the other thing we're doing, we're saying if you haven't been explored before, we make sure and add you to that open set of things we have explored. The other thing we do is we say, if we are traveling this path and we hit a dead end, if we travel the same path, if we travel a different path and cross a node we've been through before and it's shorter, we want to redirect to the shorter path. And that's why this tentative G-score is getting calculated earlier than it would be otherwise. Neighbor index. Oh, whoops. We don't want that, though. We want that to go there. We want to grab that F-score. Equals G-score of the neighbor. Oh, and actually, we have the neighbor index already. I actually don't know why I'm doing all this extra work here. If you have information, why ignore it? Neighbor index, neighbor index, neighbor index. Cool. Oh, and we need to do this distance heuristic once more. And we need to do it from the neighbor origin to the end. Okay, an F-score, so G-score is essentially how much it costs to get to that point. An F-score is how much it costs for the total guesstimated path. Because remember, we don't actually know what the final path looks like, but we know how much it costs to get where we're currently standing, and we can kind of guess a straight line distance from where we are to the end, which is how we're calculating this F score. Hopefully A star is making sense. It's kind of a bear of an algorithm to take head on, but the hope is that it shouldn't be too difficult to kind of get figured out once we know all the basics. All right. So we're just going to do one more quick check here. So I'm moving is in open set to its own variable. In fact, neighbor in open set is a much better variable name because we need to check it again. And if you'll remember what the documentation said, it said find element is a big O of n. Now that probably sounded like gibberish to anyone who hasn't taken a basic data structures class, but the gist of it is that find element looks through every single item in that array to make sure it's there, and at worst you will head through the entire list once. Now that can be really expensive, so to make sure we're cutting down on the expense, we're only doing that check once instead of doing it again right here. Ta-da! Alright. Oh, if you're not in the open set, whoops. Then we add you to the open set. And that's that. So we're actually kind of done. Or we're mostly done, I should say. At least with this. Things left. We have to figure out how we are going to return this failure. We don't ever really want to leave that in. That's something I'll figure out. I might just do the same thing as this failure up above, where we just add the start and the end point and just kind of say, alright, you're done, that's it, throw it out. That wouldn't be actually the worst thing. I'm actually going to do that. Okay, so we've got our path array, and that's done, and that's nice and clean. And that's if we haven't found our goal. Interesting. Okay. I'm going to leave a little puzzle in here for a little bit. So people are going to look at this and kind of wonder for a little bit what the heck I'm doing. Right now, if we want to delete everything, we have to pass the return failure code. There is a way to do it. The way I'm thinking of doing it, a lot of people might disagree with. But, once again, right tool for the right job. I'll let you guys kind of ponder on this for a little bit while I write my return up here. Because notice, I'm not using a full return. I'm using a break. If we return all this data that we've called new on, we will also end up missing the delete for if we return too early. So, just going to let you guys stew on that one for a little bit as I write this reconstruct path. And reconstruct path is also here. Hey, look at that. Nice and simple. We just have a current cell, and then we just go backwards through our list until we have a full path. So I'm going to leave that at the top. And when we reconstruct our path, let's see. So we start at the goal, go backwards, right? So we start at our current. And we're just going to say while current... Oh, actually, one thing I just realized I never did. The parent array for the start cell is a null pointer. We need to ensure that's in there. So while we are not staring at a null pointer, you're on the wrong line, get in the right place, thank you very much. And at the end, we say current equals equals the parent array of our current index. Good. And now we just had to add things to the path backwards. Let's see here. So when you add something to a path, it adds it to the end. We're going backwards though. So we want to add things above us. I wonder if there's an insert call. There should be an insert call. I really hope there's an insert call. It would make much more sense. Utility library, array, add element, insert element. Fantastic. Exactly what we want. Index and element. So that path array that we added at the very, very beginning. Let's see, is that current? Is that fine? I think so. Oh, we need a semicolon. And this mostly compiles. Let's see, where do you not compile? Right here. Oh, thanks. Current is a cell pointer. Oh, and you hold .3ds. Ooh, okay. We can't just slap something together. Well, let's just slap it together for now and then make it smarter later. Yeah, we'll do smartness in a little bit. So this will generate our path. So we start with the goal. And sorry, I keep closing my eyes because it helps me visualize things sometimes when I'm not actually staring at the code. But we've got our current, which is our goal. And we go in and we say, okay, you are added to the path array. And then we're going to go to the step before and add it at the 0th element, and then go to this step and add the 0th. Okay, so yeah, this works. We go all the way back until the moment we're a null pointer, then we jump and break out. Break out. Actually, it's freak out is the actual lyrics. Don't mind me. Yeah. Okay, so this is the part where people are going to make a lot of noise, probably. I need to do this correctly so that I can at least back it up. Cell graph find path cleanup. Giant freaking long label. Now, this is something that I know some people won't agree with, but I like doing this when it makes sense. And something I will always tell a beginner who is learning to program is never use gotos. Never. Like, seriously, just don't. It's a difficult tool to use. You know, this is that point where, like Mythbusters, they say, we are professionals, don't do this at home. I've used this tool before to great success, but you must be very, very careful when doing such a thing. Cool. You can do some really cool stuff with goto. 99% of the time, you don't want to use a goto. And I'll launch into this right now because I can't think of a better time to do it. Goto jumps immediately to a matching label in the same file. You can't jump cross-file. You can only jump inter-file. And you can literally jump anywhere. That's why this tool is both so powerful and so incredibly dangerous. You don't want to do something like a goto in most cases because goto can mess with the current state of your program. Because when we write something like find path as a function, there's a current inherent state inside of this function that exists, and if you just jump from one point to another without any safety checks, like I am doing right now with this goto statement, you can cause a lot of damage. Especially if you do something unexpected, you can essentially completely break flow of code. Most everybody who looks at code makes the same very reasonable assumption. Code flows from left to right and from top to bottom. I am breaking that top to bottom rule by adding this goto, which is what a lot of people will disagree with. They don't like the fact that I'm doing this because it breaks the flow. What I am using this for is right now we have a final solution that works. So I've gone through, we say, okay, we have figured out that we are now at the last possible cell. Oops, and I just realized I'm missing something else. We need the endpoint. There we go. Sorry. Continuing rant. Or continuing explanation, I should say. We are currently at the last possible point where we should technically return. This function is done. There's nothing more for us to really do. Except we called new earlier. We have created a bunch of new memory and we haven't deleted it yet. Now you could delete it here. You say, okay, delete this, delete this, delete this, and then return. And that would be perfectly fine. But remember, we also have this fail case where we have to make sure that if this while loop ever exits, this giant while open set is greater than 0. If this ever exits, we need to return a failure, and we also need to delete all the memory when we're done from here as well. In an effort to not duplicate code, and to make the code a little cleaner in this case, I am using a label and a goto. So, there you guys have it. Ways to use a goto and do it correctly. There are other cute, really cool things you can do with gotos. Don't do most of them. This is the one instance where I find a goto is a better tool than a lot of other alternatives. I know I only am ranting to 9 or so people here. Most of you may not even understand what I'm saying, but I really want to get this point across. For anyone who is a beginner and staring at me coding, I've done this a lot. Doing something like a goto is fine. And you'll notice I returned earlier because we haven't called new on all this memory yet. So there's no point for me to use the goto earlier than that. Yeah. See? Even my housemate, who just walked in and has heard none of this, looks at me funny the moment I say gotos.
That's all I heard and I'm skeptical.
Yep. It makes any programmer skeptical the moment you see a goto. I think this is a valid case. I hope this is a valid case. We'll see. Also, my music stopped. Let's go for Transistor. That's some pretty music. Also another good game. I've been going through... I went through Bastion already, so yeah. Alright. Whew. Throat's getting scratchy. But I got more water. Water bottle number 2 is ready to go. This one even has a filter in line. Not that it matters because I've already filtered all the water, but whatever. Okay, pathfinding done. We now have A star written. This must be like the 20th time I think I've written A star. But whatever. The funny thing is we don't have a use case for it right now. Actually, do we? I might be able to integrate it into the job system and make the woodcutter job, and actually any travel to location job would be able to do it. Yeah, let's do that. Let's just integrate it into this real quick, and then we can see if it actually makes a difference when we generate a bunch of crazy stuff. Oh, and I just realized we're actually not done. Remember, we have this like maximum height change, so people aren't like shooting up giant cliffs or falling down giant cliffs. We need to make use of this somewhere. So, when we are looking for valid neighbors... What is wrong, dog?
He wasn't wrong.
Okay. Well, I'm almost done with this, dog, so keep your britches on. He doesn't have britches right now, but we can put britches on him and then laugh. My shorts that are PJ bottoms look like britches on the dog. So that works out.
Nothing.
Yeah, very. So we're going to look at the height difference. Sorry, guys. I just completely, like, stream? Nah, I'm just talking with people in the house. So we're going to look at the height difference between the two cells. And we're going to use our absolute value just to make sure that we don't really care if this is positive or negative. We just want this straight up difference between the two. So neighbor elevation. That is not elevation. There we go. Elevation minus the current elevation. Elevation. And if the height difference, there we go. That's not an and, that's an or. If the height difference is greater than the max height change that we can establish, now it's getting... Excuse me. Now it's getting disregarded. Close those. Here. You are what matter. Okay. So we have to make this AI a little smarter. Before, our logic that said walk to a point didn't actually have to do much. You can see it just had little more than a destination node, and that was it. And it walked in a particularly straight line towards its endpoint. Fine. Not the end of the world. We are going to create an array of 0.3Ds, and this will be the path that it is currently taking. Alright. Now, let's just reshuffle these files around. Okay, so when you say, I would like to go to a destination, what we're first going to do... Ooh. Difficulties. No, it's not. Alright, we need to grab our game world. Lots of static casting, that's fine. There we go. And we're going to use our game world to get the terrain cell graph, and then find us a path. From, let's see, ooh. I don't have a good way to, I don't have a good way to get my start position from this, because I don't have a villager yet when this is created. Do I? No, I definitely don't, because this is a subtask, and I don't think... Yeah, I don't have that information yet. Okay. Let's see. Let's think. If path element count is 0, so if we have a fresh path that is nice and empty, we need to get a path. There we go. Much better. Because now, our character node, followed by our destination node, and you may notice I've swapped from get node position to get world position. A couple reasons behind that. One is I've started using more complex graphs, and get node position simply gets your position relative to your parent node. So there's no point in me using get node position anymore unless I want to do that exact calculation. Get world position, on the other hand, keeps all of the parents' various transformation matrices in mind. So I don't really have to worry about that at all. And max height change, I don't know, let's try 0.1 and we'll play with it as we go. And finally, the path. There we go. So we should now have a valid path after the first run of this subtask. Why am I using this controller? Oh, animations. Of course. This can always... no, that's fine. Okay, so we've got our path, we've got our controller. Now, the way we walked before was also a very direct, straight line. What we want to do now is we want to walk to the closest point in the array. And actually, we don't really ever want to add Oh, okay, the start isn't ending up in here. But I do recall adding the start to the array here. We don't actually need that. We just want the point at the end. Okay, much better. Let's see. So, what we're going to do is instead of just walking straight towards this destination node like we've been doing all along, we're now going to instead walk towards our paths. Let's see, the first point in that path. And then, let's see, if our distance from... Let's see. Oh, yeah. No, that's still fine. That's still fine. Ah, very cute, Kevin. No, the game is not done yet. The pathfinding's almost done, but not the game. Whoop, 0. So the other thing we need to do is if we are... Let's see here. If our distance to the current point we're trying to walk towards is less than a certain distance, we just want to remove that 0th element and then keep on walking. We also need one more check and check if the element count is 0, because every time we remove one, it might be the last one in the list. So we just want to make sure that if we have reached our final destination, that we do these last steps. And let's see here. Walk towards node, or move character towards node. This might have to change to move character towards point. Because as nice as it is that my AI utility exists that does this, you know what? I'm going to add another AI utility. Move character towards point. Because having that towards node might actually be really useful eventually. We're just going to copy, paste, swap this to that const reference, and you are no longer towards node, you are now towards point. Let's see. We don't have to do all that shenanery anymore. And that should be it. That should be good. So move character towards point. Where did that... Oh, where was I? Right here. Ta-da! Transistor music is so good. So good. So, they should now pathfind. When I do something crazy like... Let's see here. Let's try... Okay, I don't think there's a way up this cliff that's very valid. But let's try this to see if... Also, what the heck is with him walking so slow? Let's crank up their walk speed first, because otherwise we'll just go nuts while we wait for this guy to actually walk towards the end point. Let's make this 2.5. Make him go 5 times faster. Turbo speed. There we go, much better. Okay, so I want it to go here. So they're going to have to walk around this mountain set in order to get there. And I will be somewhat disappointed if he goes straight over it. God damn it. Oh. Well, we have a little debugging to do. Because as you can see, he did just walk in a straight friggin' line. Let's look up the construction logic real quick. Because that construction logic should not have allowed him to do that. Where is the construction logic? Let's see. Job coordinators, job logics. Travel to... Okay, we're in subtasks. Construction logic. Okay, a travel to location subtask, which should work. Crud. Means something here is unhappy. Or, actually something I didn't consider, or maybe that 0.1 is way too freaking high. Let's dump a breakpoint here, and just kind of watch it go through. So let's, whoops. I actually have no idea what they're pathfinding to right now. Alright, so I'm going to put this down. I'm trying to look for a good spot, but it looks kind of like there's no good variation here. Fine, we'll load a new world. Here we go. This looks much better. Let's put one... Ooh, little frame rate loss here. Let's put one here. And I should have... Sorry, guys. I should have put that breakpoint in before I clicked. So we'll let them cut down their trees and have their fun. And then I'm going to set... Okay, I set it here. Okay, the moment I click, let's look at some of these height differences. Okay, 0.15 is definitely greater than the 0.1, so that should cause that to skip. What else? Let's nuke all these old values. Height difference. 0.002, okay. 0.19, so we are in kind of a valid range of ways we want to walk. The question becomes, why is he still doing this straight line stuff? Why isn't he instead? Because he shouldn't be able to go down this giant cliff, right? This should be the one stopping point at the very minimum. But obviously it isn't. So if the height difference is greater than the maximum height change we can endure, it should just skip. Why isn't it? That is the question. Alright. Let's look at the reconstruction as well. Alright, so this looks nice. Also, actually, something more to think of. Maybe we just can't find a path. Okay. Already, I'm seeing a bunch of failures. And that's fine. Really? Where are you guys trying to pathfind to? Job logic. Where are you walking them? Oh, okay. Some trouble with cliffs. Alright, this giant freaking wall here should provide me with a great place to hide things behind that will force them to walk around it. Also, yeah, actually, if I put it right up against this, it should be... Yeah, that'll be a good spot, too. Alright, so I'm going to put that there. Oops. Although it seems to... What is going wrong? Or not what's going wrong, but why am I in this code? So they're trying to travel to a location. But what is that location? Okay, there's somebody still trying to walk to a tree for some reason. And he simply can't pathfind to it. So he's just walking in a straight line. Where are you? There's one guy who can't find his way to a tree. And he's holding the whole parade up. Come on, guys. Alright, let's do this again. And hope that Mr. I can't find my way to it. Actually, even better. Let's turn down the number of people again. We want one dude, and that's it. So we know exactly who we should be watching. Yes, that's nice. You can't find a path. Oh, and that's why you can't find a path. I am so sorry, buddy. That's what you get for starting on a freaking cliff. Alright. He has found his way to the tree. He has cut down the tree. Or he's at least gotten his wood worth out of the tree. So I'm going to put this down. Let's see here. And just for kicks, I'll put that there. Alright, so it's down. We have a valid start cell, which is good. And the cell count, whoo, 229 cells. We're using up an impressive amount of memory each time we do this. It's not the end of the world, but it's still a somewhat impressive amount. And then our start index is 149. And the F score, let's see here, F score of 149 is 9. Okay. That is a very, very integer-like number. Oh, haha. Whoopsies. That should not be a bunch of integers. That's what that should be. Well, that completely messes up a bunch of stuff. Alright. Bum. We load in our test world. He fails to find his way somewhere. So, it's frightening to see him failing to find his way to places so often. Like, right now, he is still failing to find his way somewhere. And because he's unable to find his way to that place, like right now, it makes sense he can't find his way somewhere. He's got this giant mountain range that he probably spawned in the middle of. So if I create this, and I'm just going to put another point here. So if I spawn it on the far side of the mountains, the parent array should look good. Just to check. 182 is null. That's expected. We have our distance heuristic, the F score, 182. Okay, that's a much better number. And the G score of 182 should be 0. Yep, okay. So, we proceed to then, we grab the current one, which is the only one in the set. That's fine. The current is not equal to the end, so we skip over this. We then proceed to remove the only element in the open set. So the open set should now have an element count of 0, which it does. This is all completely expected. The closed set has nothing. And now it has one element. Okay. We grab the cell edge, which this is it's a valid looking edge. We grab the neighbor index, which is 55. And if we look at the two indexes, 182 or 55, we are 182, so 55 is our neighbor. We grab the neighbor information. That all looks fine. What's your elevation? That looked high. Oh, 0.13. Never mind. I thought I saw like 13 point something. So the height difference is outside of our variation, right? Remember, our max height change is 0.1. So we're going to skip this node and keep going. So if it's in the closed set, and we're looking at this neighbor pointer, okay, maybe our height difference, no, we don't want to stop debugging. Maybe our height difference is a little too crazy. Oh, no, here's one. It's 0.006. That should definitely be in our list of things we can do. So we grab our G-score, that's fine. Is it in the open set? Yes. Really? Oh, here's here's a problem. We ask, are you in the open set? And it returns true, but we're checking the wrong direction. So this should be greater than or equal to 0. Granted, this is true. If neighbor is not in the open set, so if this is false, okay, and there's our problem. So it's not adding neighbors to the open set as it should. Therefore, we are failing when we attempt to figure out who is valid. Whoops. This is why debugging is a fantastic thing. Let's see here. I'm going to put some of these breakpoints back in. Also, we have a nice, once again, I love it. We have these mountain ranges here that are nice and clean. Where is he? There he is. So let's tell him to go put a house down, or a storage shed here. So that looks fine. We go in, we look at neighbors, we start adding neighbors in as we were before. So, okay, is the neighbor in the open set? No, but that's part of this, so we're fine. The tentative G-score is less than our current G-score, which is not a number. That's a little frightening too, but shouldn't be the end of the world. Okay, so we set our parent, and that's set up correctly. We set the G-score to this 1.4, that's fine. We set the F-score. I can look at that any old time, so I'll just not. Here's our open set. Here's the neighbor going in. I'm just kind of glancing at the code as it flies by. Okay, no. These all look good. And then, so here's the frightening part. We hit the end, and it's still not finding a valid path. So we're just going to walk in that straight line. Oh gosh. Why is this going so wrong? Why is it so wrong? Dang it, now I am getting hungry. Alright, let's see if we can walk a simple place, right? We'll see first if the simple case can be done. And then we'll kind of dig into whether or not it's just a bad case I had before. So it looks like I'm still getting bad cases. Okay. That's nice. Oop. Okay. So let's try... Where the heck is he? Okay, he's standing here. So after he deposits the rest of this wood, he should attempt to get a new job. There we go. Okay, so he is finding some paths alright. The question is, why isn't he finding all paths alright? There's something going wrong with this path hunting that I can't quite figure out. Let's crank this up to an unreasonable number and see if that's kind of limiting our problem. Because if that's part of the problem, then I just need to change that value. Interesting. Let's look at that AI real quick. What is he doing? Why is he stuck, specifically? Okay, game world, fine. Direction to target, bizarre, but okay. So this should be fine. So the direction to resource right now is absurdly small. What's this path point? What's its, okay. So here's one problem already. When we add... Oh, where is it? When we add points in... Here we go. When we're inserting points into this 2D array. Remember, it's a 3D array. But when we say insert element, it's doing a... Oh, what's the term? It's doing an implicit conversion between this 2D point and a 3D point. What we need to do is add elevation back in so that he has a very valid way to walk. That's fine. So if I tell him to walk here, Ah, okay, look at that. He's doing a little pathfinding now. He's doing it incorrectly, but he's still doing it. For example, you'll note he walks across some interesting tile structures to get there. Like I say, walk here. Let's see what he does. He's still dropping off wood. There he goes. So notice how he walks this bizarre set of lines before finally going to his endpoint. So it definitely is working. If I tell him to build something, let's say over here. Let's find him again, first off. Oh, there he goes. Okay, so he shouldn't be able to traverse these mountains. It looks like that's what he's headed off to do. Oh my. Okay. Oh right, but we made our distance, our max distance, stupidly huge. So we don't really mind that he walked across those cliffs. If we make it a little smarter, we should start to mind, but not at the very obvious current moment. If we make this, say, 2, which is a somewhat more reasonable number, it'll at least keep him from going off the largest of cliffs. So if I say, go here, he's still going up and down huge cliffs. Even though he's pathfinding correctly, he's still going up and down huge cliffs. Maybe this number is just way too big. Maybe it needs to be like 1. I should honestly probably just have some kind of like debug tool. Maybe that's what I'll do. I can do that later. Okay, for getting here. Okay, note he's not going to the nearest cells. He is kind of going around some of these larger edges. Now, granted, he still went down this stupidly huge cliff. And that's a little disappointing. I wonder if I keep turning this down, if he'll eventually do a somewhat reasonable task of walking from point A to point B. Yes, yes, Kevin, I see what you're typing. So the idea I had was not actually something that draws paths, because if I drew paths, that would be something I'd have to add to the world, and it's not exactly something I want to do. My idea was something more along the lines of a tool that would allow me to mouse over something and then type in, like, elevation check. And it would tell me the elevation of whatever was under my mouse cursor. But notice, look at this. He went around the mountains. Very nice. And now if I tell him to go back by, oh, come on, there. Let's see where he goes. So he goes in, he drops off the wood he's got. He should get a new path. And off he goes. Man. Okay, there we go. But look at this. He's avoiding those big cliffs. He's definitely working his way around some stuff. I saw him clip a little bit on this corner, which is not good. But it's not the end of the world that he does that. Oh, so much better. So much nicer. All right. Cool. In this case, the elevation distance actually is something that's part of the heuristic. It's not getting ignored. I started to ignore it and then decided against it. Whew. Cool. Task done. Now he is doing some silly things. You'll notice that he is walking through the tile that he is currently inside. So let's remove that, because that seems like kind of a silly thing to do. We're just going to grab the path array. And actually, let's see here. While the parent array of the current index is not equal to a null pointer. There we go. So we'll skip one early. So he shouldn't do any crazy, whoops, he shouldn't do any crazy things at this point. If we tell him to walk, here's some mountains. If I tell him to walk, is there even a way around? Let's try it. Let's see what he does. So he is going around. And he's going up and down some large cliff edges, but it's not the end of the world. I can keep just cranking this number down until he either stops finding valid paths, or I can crank the number to kind of a more reasonable point where, sure, you know, he's able to find a path. And maybe we can make it smarter later and say, well, maybe they don't want to climb elevation quite so much. He's finding a very interesting way to the closest tree that was next to him. But once again, we'll get to see this in action. So he goes in, he cuts on the tree. Oh, I can't see his inventory yet. I'll add that eventually too. But now you see him, he's walking around. He will construct the building and then proceed to drop off his supplies at that building. Fantastic. Exactly what we're hunting for. Whew. Take a little bit of a load off. That was a task that I thought would be far too large for tonight. And yet, it's done. Which is kind of ironic, because I've taken up tasks before that I thought would be too small for a stream and ended up spending a stream and a half getting them done. Hilarity ensues sometimes. Anyway, so, guys, thanks for joining me. It has been a blast to get this working with you all. If you have any more questions, please feel free, ask away. Although at this point, I need to make dinner because I'm getting hungry. Having passed on enchiladas, I need to get something in my stomach aside from water. Also maybe some chapstick, because holy heck, I talk a lot. A lot. So, it works. Oh, I should probably commit the code, huh? Let's do that while I wait for questions and while I figure out where things should go next. Let's nuke those. Okay. Adds basic A star pathfinding to the cell graph. So we've added our A star in, implemented find path, and used functionality when moving AI between 2 points. The coup 22. I'm sorry if I got your handle wrong, but any tips for someone that's taking a beginner's C++ class at college? Sorry, I kind of garbled that. Let me try it again. Any tips for someone that's taking a beginner's C++ class at college? What, puppy? Pick a goal, work towards that goal. That's really the easiest thing you can do to get yourself on the right path. Find something in programming, if we're not talking game design, if we're talking just programming, find a part of programming that interests you and that you like to do, and pursue that to your heart's content. For example, I got a friend, thank you, the dog just brought me a ball and dropped it on my foot. Yes, you're adorable. So if we're talking just any C++ stuff, I would say find something that interests you and go do it. Oh, right, the example I was using. A friend of mine just started, one sec, puppy. He's pestering me to play. A friend of mine just started taking C++ classes herself. She decided that she was most interested in database stuff. So she is becoming a small-time guru and actually already knows more than I do, which is not difficult when it comes to databases, but she knows quite a bit about databases already. Between databases and system administration, like, she's got that set. She's not a huge fan of games, though, and that's fine. She has picked her goal as learning databases and making that her specialty. If you want to make games, as Night Soma here is kind of expressing his desire to do, pick a game and pick something very simple to start with as your goal. Make Pong, make asteroids, make missile defense, right? Do something very simple that you are certain you can do. Then work your way up the ladder of things to do until you end up where you want to be. So for making this giant game, I've spent a lot of time making a lot of smaller games. This is my second foray into 3D, so I've got some knowledge of what I want, but I'm still learning a little bit too. So this is not all completely rote and easy, but it's still something that I have to work hard and learn to finish. So yeah, just the easiest thing you can do. Pick a goal, one that is within reach, and go for it. And good luck. Programming is definitely something easy, and Naito-sama, I would say that even if you don't have a lot of money, you don't need much. You need just a computer, a compiler, and there are open source art websites that will get you a fair hunk of the way. Unity is free, so if you want to learn C++, maybe a different engine would be used, but use C# then. Or, you know, find a free, there are free C++ engines out there that you can use. You know, something 2D. I'm reading your chat and it looks like you've already done Pong and jumping to Arkanoid. That's fantastic. You are on the right path already. You're actually a lot further than a lot of first-year students will ever be at a university. First-year students spend most of their time just learning the basics of language, and only when they are done with the basics of language do they actually go into a class where they actually make a game. And that takes them, I think you've been in school for 2 or 3 quarters at that point. I think 2 maybe. Either way. So, good luck. You guys are, you know, both of you seem to be on the right track. Classes at college are a great way. Community classes especially are how I learned C and C++. So you're definitely on the right tracks. Hang in there. I know it can get a little crazy sometimes, but it's well worth it, at least in my opinion. I think programming is one of the greatest things ever. That's how I managed to do it 8 hours a day and then come home and do it for another, I think it's been, I started at 7-ish? So it's been 2 hours. So I'm now up to 10 and a half hours of programming today. How it goes. I found something I love, and this is what I love to do. I write pathfinding, I write gameplay, and I love it. Alright, so I should probably commit this code. I've been staring at this for a while. Using height differences as a filter. There we go. Cool. Nice and detailed, so my partner can check on my code and know what I'm up to. Yeah. I don't really see any more questions, but yeah, I'm glad you guys, you know, there are lots of resources online and around and available. I may not be the best resource because my time is unfortunately severely limited, and I'm already tutoring a number of people in programming. But I'm still happy to stick around after stream some days when I have the time and answer questions and kind of do what I can to help. If you guys really like what I'm doing and you want to see more of me making games, or making my own game I should say for now, then please feel free, follow. There's a follow button beneath me, and eventually we'll have gameplay that will not only make sense, but will actually be incredibly useful and fun to watch, hopefully. We'll see. We got to get there first. Let's see. Actually, I think I have one more thing I can do before I go, which is go to my to-do list and take this and dump it on the done list. I don't know why I keep dumping things on the bottom. I should probably just be dumping them on the top. Whatever. Assign jobs. Yeah, this is all fine. Cool. And you guys have access to that Trello in a link down below. So if you want to kind of see what's up and coming, or I'll keep adding to it and messing with it as I go. But you know, if you want to see what my to-do list currently looks like, as messy as it is, it's in a link below. So, I'm not really seeing any more questions. Thanks again for joining me, guys. Those of you who are new here, sorry if you just caught on, but I am unfortunately signing off. I just completed Pathfinding today, and it is definitely a lot of fun to kind of see in motion. So thanks again for joining me, guys. I will be back online at the very, very latest on Saturday or Sunday. Probably Sunday, but I'll also have streams in the meantime as well. Also, I'm slowly putting my other streams up on my YouTube channel, which is also linked below. So if you want to kind of catch up and see what you've missed, also a good place to go. Thanks again, guys. Have a good rest of your day, and if you're learning programming, good luck. Later.